All right. Yeah, welcome back. We are looking at another non-parametric test called uh, Kruskal-Wallis test. Kruskal-Wallis, so uh, it's equivalent to one-way ANOVA, right? So that's what we are looking at now, Kruskal-Wallis test. So it's equivalent to one-way ANOVA test. Remember last time under parametric, we look at one-way ANOVA. In this time, we want to look at a Kruskal-Wallis, which is equivalent to one-way ANOVA. When the assumption, parametric assumption for one ANOVA is not cannot be is violated, so you can switch over to Kruskal-Wallis test. All right, so it takes one numerical variable and one categorical variable with more than two groups. All right, more than two groups. So two groups, that is for the one we just finished last class. All right, so but this one is looking at more than two groups. So now what does it mean is to compare the medians of more than two groups. The same way we did for ANOVA, one way ANOVA, more than two groups. That used median, all right, to compare more than two groups. But here we are using, that's using mean. ANOVA use one way ANOVA use mean. So here we are using median because it's based on ranking. All right. So Kruskal-Wallis test by rank is a non-parametric alternative to one way ANOVA test, which extends the two sample Wilkinson test in the situation where there are more than two groups. All right. It's recommended when the assumptions of one way ANOVA test are not met. All right. So when the assumptions of one way ANOVA are not met, then we switch over to this non-parametric test called Kruskal-Wallis. All right, so here we use the poultry dataset we have used before actually, which come along with the car library. All right, so library is installed by default. You don't need to install it. So just load the data, just load it library here called car, then load the dataset called poultry. Then we can link this again, which we have done before. So we have 4 sites here, 4 sites. So how do I know? So you can just table it here and just do this. So we have 1, 2, 3, 4, 4 sites. So I've already glimpsed. You can also check using this method, using a question mark to check more about this particular data set called poultry, which I have done before. So we can just go ahead and do that. Now, if you want to know more, so now we have 4 sites here. We have a element here. These are chemical composition on each site. All right. So we want to know. I want to do so. Last time we used aluminium, if you remember, because aluminium was passed the test of parametric. So from all these ones, but now we want to use another one here called magnesium. We could have used other ones because all other didn't pass the test as well. So we want to first check assumptions. Are the data from each of the 4 groups follow a normal distribution? So we are passing Shapiro. We use our Shapiro to test, and we look at magnesium. So it's highly significant, 0.001. So which means that it failed the test. So here the non-hypothesis of normal distribution is rejected. We have for this particular p-value for magnesium. Therefore, normality test failed for magnesium. So we can continue with non-parametric test of Kruskal-Wallis. All right. So that is what it means. So we can go ahead with our test. So we're asking some questions such as want to test whether the median of magnesium composition differ in the 4 sites. All right. So we want to know if there is any significant difference between the composition of magnesium in the 4 sites. That's what we're trying to say. All right. So we can now come up with a hypothesis here, and maybe now we can say the median in the magnesium composition is the same in the 4 sites. All right, which means that there's no difference. Or alternative can say the median in the magnesium composition is not the same in the 4 sites. This means there's a difference. All right, so this is what you're trying to say. So that is our hypothesis. So we can reject any one of them later based on our result. So let's create a box plot as usual to first check the median and standard deviation. If you want to also check the hierarchy, we can do that. So let's say we pass our poultry here as usual. Can we attach poultry? Let's attach poultry. Maybe you may need it later without using $sign to invoke each variable or column. So we just pass our poetry here. Our site is x-axis down, then our horizontal axis is y is magnesium. So we fill it by site, which is color, so to see the color of each site. So when we run this now, we don't want to see the legend because we already show color to. So this is what we have. All right, for each side, this is what we have. Okay. All right. So all right. So you can see the difference. Can we log? Can we log this magnesium? It look as if. Let me see if you can log. Maybe the data can look better. Okay. Let's see. Let's see. Let's see. Let's see. Let's see. No, not much difference. So you don't need to log. So just remove the log. All right. So I thought that will improve the data. All right, so okay. All right. So now we have our data plot. Then we can also group now. We can say okay, our group variable is site. Then we have our data set called poetry. Then we can summarize, find the median, count, SD if you want SD. So just we have done this several times, so you can do it again. All right, so we have the site here, each of the site here, and we have the count on this site. We have the median 0.6, 3.86, 0.67, 4.48. You can see they are not the same, even though this one and this one they are very close. Okay, as terms and the Ashley raves, they are not too far. Okay, in median, but they are not the same. Okay, so which means media is unique, is different across the four sites. By this particular summary, we can see that there are differences. Okay, and by this table also, and by this plot also, you can see they are not the same exactly. All right, so but we want to know that this our observation is it significant or is just by chance. So then we can go ahead and do our test, compute a Kruskal-Wallis test. Just call Kruskal.test. We pass our MG, which as our numerical data. We pass our group data his site. Then we see data equals to poetry. We run this. All right, so the p-value is 0.00026, so which is highly significant. So we can summarize the result. Okay. Oh, sorry. It was not need to summarize. This is not for this for not for now. So this is just a direct test. This is not a ANOVA. Okay, ANOVA we do that. So now we just use a direct test. Okay, we have our result here. Okay, so we are going to do pairwise later. We do pairwise later. Okay, now as the p-value is less than the significant level 0.05, we can conclude that there are significant differences. Okay, in the maximum composition between the groups, right? Which is the four sites. Okay, all right. So therefore, we reject no hypothesis which says that there is no difference in the favor of alternative hypothesis, which evidence that there is a difference with a significant p-value of p less than 0.001. Okay, so that is just our report, but we can still do some advanced investigation to know this significant value we get here now. Is this for the first site? Is it all the does it happen in all the four sites, or is it driven by just one site? Okay, that's what we want to do now. We want to do multiple pairwise comparison between the groups. Is this significant being driven by a particular site? Because sometimes if a particular site is significant, all can be significant. But you want to know which particular one that is significant, which one that caused the value to be significant in the first place. Is it driven by only one site or more than one site? So from the output of the Kruskal-Wallis test, we know that there is a significant difference between group sites, okay, but we don't know which pairs of group sites are significantly different. All right, so it is possible to use the function pairwise with constant test to calculate pairwise comparison between groups levels with correction for multiple testing. So we can use either Benjamin or Bonferroni and so on for our test for our adjustment p-value. So we can call this particular function here now, all right, this test, and pass it this pairwise and pass our magnesium here. Now that we have attached we can use this MG only that we have attached our site. Okay, I mean our poetry. Do we have attached? I think we attach. yes, we attached, so we can use this directly without passing the mgd anymore, I mean $sign. So let's run this now. Okay, it's run, but it's giving me some kind of a warnings. Maybe because I removed it. Let me see if that is because of that. Is the warning not supposed to come, or is it because of the not factoring? Okay. Let me see if I can factor this. Let me see if that can work to reduce the error. Let me see again. Okay, that's not a problem. Okay, never mind. So that's a remove factor. That's not just giving us some warning. Right? Don't be disturbed by the warning. So we have our result shows here that in the PS we have uh, this particular lane down here is significant. All right, with you can see actually raise. All right, I think then we have also hassle turns with a lane dines here also same. So only this and this that are significant. All right, so it means the pair, these two pairs that's significant, and this that make this data significant. We use a not Bonferroni, we use a Benjamin for our P further adjustment, so we can use a Bonferroni as well. All right, so just change to bone. For example, can just change to bone here, like so. Yeah, so that's the Bonferroni. So let's see. So we can see the same data. All right, but just that one is more conservative and stringent than the Benjamin. All right, so it can be seen from the output that only two pairs sites are significant with their adjusted p-value using Benjamin and Ochbach. So that is what we discover here, what we observe here. So not all of the sites that are significant. All right, so that is just that about a ANOVA, non-parametric ANOVA, which is a Kruskal-Wallis. So you can just go ahead and do the same and do your testing as you deem fit. So I will see us in the next class where we look at another test on non-parametric tests. Thanks so much for listening. If you are not yet subscribed, you can go ahead and do that so that you can see more of the videos as being posted. See you later.